All right, so we're looking at ideal gas law type problems. We have our equation here, PV equals nRT. And so another type of problem would be that they give you initial states and finals, and then they ask for some kind of final state. So for example, they tell you the pressure at 0 degrees Celsius is this, and then they ask you what's the pressure at 100 degrees Celsius. So the trick to kind of solving this is to first reorganize this equation to isolate R on one side. So we're going to divide both sides by NT. So it's PV over NT is equal to R, right? And so we know it's an ideal gas, so we know it's behaving according to PV equals nRT. So we could just subscript these as ones, right? Say that the initial state, PV equals nRT. Well, in the final state, PV also equals nRT. Right? It's an ideal gas the whole way through, so this is always true. And so we can reorganize this equation, isolate R, and get PV over NT. And so if they're both equal to R, they both must be equal to each other. And so the equation is just P1V1 over N1T1 equals P2V2 over N2T2. The only trick here that you have to be careful about is that T1 and T2, both of the temperatures, must be in Kelvin. The other stuff can be in different units, but the temperature must be in Kelvin. And then the second part, similar to some of the other problems, is that you assume that the rest stays constant. So let's take a look at an example. So we'll just do two examples. So we'll say that the pressure at 297 Kelvin is 360 kilopascals. What is it at 323 Kelvin? Right, so let's think about what equation we're going to use. We're given sets of initial and final. We're given, under conditions 1 and under conditions 2. So we want to use this P1V1 blah, blah, blah equals P2V2 type of thing. And then we think about what the question here is giving us. So in this case, it's telling us that one of these temperatures is 297 Kelvin. So we'll say that it's initially 297 Kelvin. And at that temperature, its pressure is 360 kilopascals. And then it says, what is it at 323 Kelvin? Well, it can't, that has to be the final set. That can't be also the initial one. So we can plug that number into there and think about what is it asking. It's asking for pressure, right? It gives you pressure, then asking what is it at a different temperature. So what we want here, that's our unknown. So what do we have to assume about all the other stuff? Well, we assume that it just stays the same. So we're just going to ignore them. It's going to stay the same on both sides, so they're all going to basically cancel out. And so then our final equation here is P1 T1 equals, or P1 over T1 equals P2 over T2. And then again, just kind of recheck out where you're going to plug your numbers in. Right, and then you want to solve for P2. So I'm just going to write plug in chug. And you should get a P2 of 390 kilopascals. Notice that we didn't have to go to atmospheres here because R is not really involved in this equation. So you can use whatever pressures, whatever volumes. Still got to go with number of moles, and temperature must be in Kelvin. But pressure and volume, you can use different units of pressure and volume. Another example, basically the same question. So 0.300 liters at 10 degrees. 10.0 degrees Celsius. What is it at 30.0 degrees Celsius, right? So again, we're given two sets of conditions. So, 1, 2, we want to think P1, V1. Cool. And then we want to think about what we can plug in. Well, we got 0.3 liters. We're going to say, oh, that's what we initially have. And then we got 10 degrees Celsius, 10 degrees Celsius. Cool, looking good. And then 30 degrees Celsius. Okay, so that's going to be the final temperature. So we'll plug that into there. And then kind of what do we want? Well, it gives us the volume, and then it's later on asking us what's the volume. So we want the volume. What do we do with the rest of the stuff? We basically assume that it cancels out, and so all this stuff just kind of gets deleted out of here. It's constant in both cases, so it cancels each other out. And then what you're left with is V1 over T1 equals V2 over T2. And now, can we just straight plug and chug? The answer is no. The answer is no, right? Volume and pressure, they're allowed to be whatever units they want to be. But in order for this equation to work, temperature must be in Kelvin. So we've got to change these to Kelvin. So if you think about what we're going to do, we're going to add the 273.15. So this will end up being 283.15 Kelvin. And then this one here will be 303.15 Kelvin. So now we can plug and chug those in there. Just highlight it again. And remember, what we want to solve here is for V2. And take a look at your units. Everything will cancel out nicely to be left with volume. So your V2 at the end is 0.321 liters. So just be able to do these kinds of plugging and chugging problems. And really the trick to this question is to be able to go from PV equals nRT over to this P1 V1 over N1 T1 equals P2 V2 over N2 T2. You can memorize it, or you can just simply use the equation to get there.